Everyone, this is a lesson over solving quadratics by square roots. It is Digital Learning Day number 5. You made it through a whole week of digital learning days. Our objective today is I can determine the best way to solve a quadratic equation. We've actually done a little bit of solving already, but we're going to kind of further that process looking at different ways to solve it most efficiently. Please remember to make sure you're reading the daily announcements and checking Canvas messages, as well as completing the work session for the day. And any work sessions that you've missed this week or want to reattempt, just shoot me an email and we can talk about that. So again, we have actually solved quadratics before, not by this method of square roots, but it's a pretty easy method to figure out. And again, the biggest problem is just determining when to use the method of solving by square roots and when to use a different method. I did put a note-taking guide in Canvas for y'all as well. So if you have a printer or if you are like me and have a stylus and a pen you can use to fill it out, feel free to have that pulled up as well. Let's get started. So solving quadratics, just a reminder, what that means, if I asked you to solve a quadratic, it would mean to find the x-intercepts. If you remember from our previous conversation in a lesson earlier in the unit, and with that poster on my wall that I have, the words solutions and x-intercepts and roots and zeros, they all mean the same thing. We're all looking for where the quadratic crosses the x-axis. That's what it means to solve or find solutions. That's what x-intercepts are referencing. The word roots is going to start to come into play in this part of the unit. And the idea of zeros as well, where the parabola crosses the x-axis. So we've discussed 5 different ways, or we will be discussing 5 different ways. Some of them we've already discussed on how to solve quadratic equations. The first way is factoring, which we've done quite a bit already. We've factored when a is equal to 1, when it's not 1, and special cases. We've also solved by graphing. That's just looking at a graph and saying, hey, here are my roots, here are my x-intercepts. There's also solving by square roots, which is what we're going to focus on today. Completing the square to solve, which we've done completing the square to figure out what vertex form is, but we can also complete the square to solve a quadratic. And there's another item called the quadratic formula that you'll learn about next week. So again, today the one that we're going to focus on is solving by square roots. So we're going to look at a few examples of that in a moment. Let's just start by when we approach any solving quadratic equation question, what it's asking us to do. So let's read our first paragraph. Whenever we're solving a quadratic form or a quadratic equation, try first to solve the equation by factoring. Be sure that your equation is in standard form, which is ax squared plus bx plus c, before you start your factoring attempt. Now, this part I want you to underline in your notes. Don't waste a lot of time trying to factor your equation. If you can't get it factored in less than 60 seconds, you can move on to another method. And again, those are the methods we kind of talked about a few minutes ago that we'll address throughout next week. But today we're going to look at the method of solving by square roots. These 3 right here are examples of questions that you could easily factor, or they're already in factored form. This first one we could factor easily because we see a 1 in front of our x squared. The second one is already in factored form, so I could easily figure out what my 2 zeros are. This last one, if I factor by GCF, I could also easily figure out what my 2 zeros are. But again, let's say we look at a problem and it's been about a minute and a half and I haven't even started to factor it. I'm not sure how to do it. Let's move forward and see if there's another way. The other way is called solving by square roots. So next, let's look at the side of the equation containing the variable. Is that side a perfect square? If it is, then you can solve the equation by taking the square root of both sides. Both sides of the equation. Don't forget to include a plus or minus sign. Underline that a few times as well. Don't forget to include a plus or minus sign in your equation once you've taken the square root. So let's look at the 5 examples, and I have these examples laid out on your note-taking guide as well. Let's figure out how we would solve these by square roots, and we'll actually look at it on Desmos as well to kind of prove that we're correct in what we're thinking. Our first example is our simplest one. Example 1 says x squared equals 9. So I noticed that my constant term of a 9 is a perfect square, so I know I can take the square root of both sides of the equation. So let's go ahead and do that. Take the square root of both sides. The square root of x squared is just x. And the square root of 9 is either positive 3 or negative 3. This is where that idea comes in right here. Do not forget to include a plus or minus sign in your equation once you've taken the square root. We know that 3 squared and negative 3 squared both make a positive 9. So it's important to include both of our zeros of 3 and negative 3. So what we just did again was solve our equation using square roots. So I know that this parabola is going to cross the x-axis at 3, 0 and negative 3, 0. And that is how you write your answer when you solve a quadratic. You write them as points. Or you can write them as x equals a number, x equals another number. Let's check and see what that looks like on Desmos. Here is Desmos. And if you look at our first equation, we do have negative 3, 0 and 3, 0, just like we predicted on our equation. Let's try our next problem. In this one, it gets a little more tricky because we realize that 12 isn't a perfect square, but that doesn't mean we can't solve it. So in solving our second question, we have x squared equals 12. Again, even if it's not a perfect square, then we can still take the square root. We know we're just going to have a little bit of a decimal part to our problem, though. Take the square root of both sides. We know that the square root of x squared is just x. The square root of 12, and you can use a calculator for that, is approximately 3.5. So I'm going to round to the nearest tenth. X could be 3.5, or x could be negative 3.5. And if we wrote those as points, we would have 3.5, 0, negative 3.5, 0. Let's take a look at Desmos to see what that looks like. If I turn off this graph, turn on the next one. If we look at our two zeros, we've got negative 3.464, which I rounded to 3.5, and 3.464. Again, we can prove that we're right just by checking with Desmos and our x-intercepts. Let's try our third question, amping up the difficulty just a little bit. I put a note on there just to have you notice that when we're solving by square roots in this example 3, I noticed that our b value is missing. So keep that in mind. You could either look and say, oh, is that a difference of squares problem? Or you could solve by square roots. So our third example is 3x squared minus 15 equals 0. So before we solve by square roots, let's just get everything let's get that negative 15 over to the other side. That way we can actually take the square root of individual terms rather than a binomial. So I'm going to add 15 to both sides, and we end up with 3x squared equals 15. Now I still have this 3 here, so I'm going to actually divide both sides by 3 to get my x squareds completely by themselves, and then end up with x squared equals 5. Now I can take the square root of both sides, now that I just have an x squared there. Now if this number would have been a 4 or something, we would have totally been able to take the square root right away, but since it wasn't a perfect square, I wanted to get rid of it. X squared, the square root of that is just equal to x, and the square root of 5, if you use a calculator, is equal to 2.24 in this case, or negative 2.24. And to write that as our solution, we would write 2.24, 0 and negative 2.24, 0. Move that up just a little bit. There we go. Perfect. Again, let's take a look and see if those are actually our x-intercepts on Desmos. Go back to my screen, highlight my 2 points. There's my negative 2.236, and there's my positive 2.236. So again, I know we're correct. All right, let's look at our fourth example. We've got 2 more to go. Y'all are doing great so far, I'm sure. And if you have questions, you can write them in the margins and just join our conference later to ask me some of them. Example 4 says x squared minus 81. Now I pointed out here that this is actually a difference of squares problem. So if I asked you to factor it, you could really quickly just tell me, oh, okay, I've got x minus 9, x plus 9. Do you know why that is? You can go back and watch one of my videos to figure it out if you're not sure. Now from here, again, let's get the 81 on the other side by adding it to both sides of the equation because I want to get that x squared by itself. So now I have x squared equals 81, and I can take the square root of both sides. You'll have x equals 9 or x equals negative 9 because, again, whenever we take the square root of a number, we could have a positive root or a negative root. So I know that the two x-intercepts are 9, 0 and negative 9, 0. Just to double check, we can use Desmos to help us. I look, and there we are, 90 and negative 90. All right, let's try our very last one. This is the most difficult one, but it just takes another step or two to figure out the work. Nothing we can't handle. So example 5, we have x minus 2 squared minus 16 equals 0. And when we look at this question right here, I'm trying to figure out how to get x by itself. If you notice on example 1 and on example 2, x squared was by itself in this case, but the original equation, if we were to reverse this, was actually equal to 0. We were solving for x because we had it equal to 0. By moving 9 to the other side, we just started the process of solving. So here, let's again start that process of solving by square roots. We add 16 to both sides, and we're left with x minus 2 squared equals 16. Now, this whole quantity is being squared. So I can undo that operation, just like how subtraction undoes addition. I can take the square root of that whole term, same as over here, take the square root of the whole term. So now I have x minus 2 equals either 4 or negative 4. Now, since we still have one more step to do, let's write out this problem right here. Let's write this out as a problem with two different possible answers. X minus 2 could be equal to 4, or x minus 2 could be equal to negative 4. Here, I add 2 to both sides, and I get x equals 6, or 6, 0. On the other one, I still add 2 to both sides, but I end up with a little bit different answer. I end up with x equals negative 2, or negative 2, 0. So this process should be a little familiar to you. The idea of solving for x, but we're just formalizing that just a little bit. Let's go ahead and check our answer for this one using Desmos. I have graphed that equation, and if we take a look at our parabola, I end up with negative 2, 0 and 6, 0, exactly what I predicted from our problems. So solving by square roots, whenever we go through this process, what we're looking for is if you have a perfect square that we can solve, if we're missing a b term, if you notice difference of squares, and if you're just looking to take the square root of a certain term or a certain x squared or an x value that you have. So in this case, we could take the square root of this term. Here, we took the square root of just our x. So now you're ready to start your work session. There is a solving by square roots Canvas quiz for you to take. Please email, Canvas message, or Canvas chat me if you need help. And remember, I'll also be on a conference, a Canvas conference. During this time, you can click on that and you are welcome to chat with me there, or we can work out some of the problems as well. Good luck and happy Friday.